In this video, we review the acetylation reaction mechanism between alcohols and acetic anhydrides under acidic conditions to give esters and carboxylic acids. So the carbon of the acetic anhydride is going to be our electrophile. Remember that the oxygen is electron withdrawing, so it's going to pull electrons towards itself, leaving a partial positive charge on this carbon. So this carbon is going to be our electrophile. The oxygen of the alcohol, on the other hand, has lone pairs of electrons, so this is going to be our nucleophile. However, one thing that you should remember is that alcohols are not really strong nucleophiles. So for this reaction to go forward, we either need to make the alcohol a more reactive nucleophile or make the acetic anhydride a more reactive electrophile. And that's what we're going to do. So the second one is what we're going to do, making the acetic anhydride a more reactive electrophile. And that's the whole purpose of using the acid catalyst. Let's dive into the reaction mechanism now. So in the first step, the oxygen is going to get protonated as we have acid floating around, and now the oxygen has a positive charge, so it's going to pull electrons even more towards itself, and this is going to make the carbon a better electrophile because it even has more positive charge now. In the second step, our nucleophile, or the oxygen, is going to attack our electrophile, and because the carbon cannot have 5 bonds, we're going to break this pi bond like that. And this gives us our intermediate here, so this is our tetrahedral intermediate right here. In the next step, we're just going to do a proton transfer. So if you look at this intermediate, this oxygen is positively charged, so it's not really happy, as oxygen do not really like to be positively charged, and because we have the conjugate base of our acid floating around in the solution, it's just going to deprotonate that oxygen to give us this intermediate right here. And we usually call these steps in reaction mechanisms proton transfers. So this step is just a proton transfer. Now if we look at this intermediate here, we can identify a good leaving group right here. This is a carboxylate anion, so we have a good leaving group, and it's being shown here as well. So remember, the carboxylate is a good leaving group because the negative charge can be stabilized through resonance, and that's why this is a good leaving group. The next step of the reaction mechanism is then that these electrons on the oxygen will help to push out this leaving group like this to give us this intermediate here plus the carboxylate anion. So we're almost there. We have our ester plus the carboxylate anion. The next step is just again proton transfer. This oxygen is positively charged, not really happy, so it's just going to lose that hydrogen. It becomes neutral, and because we're in acidic environment, this carboxylate is just going to get protonated, giving us carboxylic acid. So again, this is just another proton transfer. And that's the mechanism for acetylation. Let's just do a quick review. We started with acetic anhydride right here, acid catalyst plus alcohol, and it gives us ester plus carboxylic acids.